Hello everyone. Today we are going to discuss the problems on current divider rule and voltage divider rule. So in this, the equivalent resistance of four resistors joined in parallel is 20 ohm. The current flowing through them are 0.6 amps, 0.3 amps, 0.2 and 0.1 respectively. Find the value of each resistance in the given circuit. So they given only the question, circuit diagram is not given in the question, so we have to we have to frame the circuit diagram in the solution. So for the circuit diagram, if you solve this, if you frame the circuit diagram, you will get 1 mark. Okay, they ask for 6 marks. This is for 6 mark question. And then here the current, I'm just naming the current in this resistor is I1, I2, I3, I4. So like this I named this. Next, we are supposed to find the total current. So total current as per the Kirchhoff's current law, incoming is equal to outgoing current. So incoming current is I, outgoing, whenever it is coming to this junction or branch, this node, we are having 4 branches, so the current is going to divide I1, I2, I3, I4 as per the question. So the total current is 0.6 plus 0.3 plus 0.2 plus 0.1, so we'll get I is equal to 1.2 ampere. Now V is equal to IR. So from this, the total resistor is given in the question. That is how much it is. It is 20 ohms. That is, R total is 20 as given in the question. So we know the value of I, and then we know the value of R. So V is equal to 1.2 into 20, will get 24 volt. So up to this you will get 2 marks. So totally it is 3 marks. And then here we are supposed to find the resistor R1, R2, R3, R4. As formula we know that according to Ohm's law, R is equal to V by I. So since it is a parallel circuit, in a parallel circuit the voltage will remain constant. The 24 voltage will remains, it will be across the R1, R2, R3, R4. So here I is equal to V. V is a constant value, and I1, I2, I3, the current value get different. So R1 is equal to 24 by 0.6. We get 40 ohms. Here also it is R2 is equal to 24 by 0.3, 80 ohms. R3 is equal to 24 by 0.2, 120. Like that, R4 is 240. So for this you will get, for each you will get half of marks. So if you get half of marks means it carries totally, here it is 2, 2 plus 2, 4, 4 plus 1, 5 marks. So like this the mark split up is given. So this mark split up is very important, because simply many students what they will do, they will write the formula and get back, so they won't get the marks. Finally we have to get the answer. Okay, next problem. See here, a 10 ohm resistor is in series with parallel combination of 15 ohm resistance and 5 ohm resistance. If the current in 5 ohm resistor is 6 amps, what total power is dissipated in the 3 resistance? So in this, according to the question, I frame the circuit diagram. A 10 ohm resistor is connected series with 15 ohm and 5 ohm parallel resistors. 15 ohm and then 5 ohms are connected in parallel. Just I am considering the this 15 ohm is a R1, 5 ohms is a R2 resistor, and this is your R, total R resistance, and this is the total current I. The branch, the current in the R is R1 is I1, current in R2 is I2, I just named. But here the question, they given only I2. So note, in a parallel circuit the voltage will remain constant, so that 30 volt will be present across 15 ohms also. This is the given question. So here, see here I2 is given, R2 is given. So V is equal to IR. So I value is 6 and then R value is 5. So we'll get 30 volt. So this 30 volt will remains in this 15 ohms also. Across this 15 ohms also we'll get the 30 volt. So V is equal to 30 and then R is equal to 15 ohms in this branch. So just I am considering this as a I1 is equal to V by R1. V is 30 and then R1 is 15 ohms. So we'll get I1 is equal to 2 amps. Then if I1 is equal to 2 amps, according to KCL, Kirchhoff's current law, incoming current is equal to outgoing current. Incoming current is equal to outgoing current. So in this case, so I is equal to I1 plus this I is incoming, I1 and I2 are the outgoing, because this is the junction. Whenever the current is entering here, this I1 and I2 are the current away from the junction. So this I is incoming, I1 and I2 are the outgoing. So we know the value of I2 already given in the question, that is 6 amps, and then I1 just now we found that is 2 amps. So if you substitute, we'll get 8 amps is your total current. So I is equal to 8 amp according to the question. So and then what we have to find what total power is dissipated in the 3 resistor. We are supposed to find the total power in 3 resistor. If it is a circuit, it may be a series circuit or parallel circuit. Simply we have to add all the powers and then find the total power. This is your total power. So here already we know the formula. P is equal to VI, P is equal to I square R, and P is equal to V square by R. So in this formula is opted because we know the value of current and then we know the value of resistor. So I am opting this formula and then I am substituting the value. So here it is I into R, so I square into R, so I square into R. Here also I1 square into R1 and then I2 square into R2. If you substitute the value, finally we are getting the total power is equal to 880 watt. I hope you all enjoy this video. Subscribe the channel and get the notification and click the bell button. Thank you very much.